Hello there, and welcome to a quiet place where time moves differently. Tonight we're stepping away from the rush of daily life and into the hushed sanctuary of winter woods. Here, beneath snow-laden branches and among towering sentinels of oak and pine, we'll discover a world that whispers rather than shouts, where every breath of cold air carries stories older than memory itself. This is your invitation to slow down, to let your shoulders drop, and to walk with me through forests transformed by winter's patient touch. We'll explore how these ancient woodlands survive the harshest months, how they prepare for renewal, and why their winter silence holds such profound peace for those who take the time to listen. If you find comfort in these gentle explorations of the natural world, feel free to like and subscribe, or simply share a thought in the comments below. It helps others discover this quiet corner where wonder and rest meet under starlit skies. But for now, let's begin our journey into the winter forest, where every step crunches softly on snow and every tree stands as a monument to endurance. Winter forests hold secrets that summer never reveals. When the last autumn leaves have fallen and the first serious snows have settled, something magical happens in the woods. The landscape strips down to its essential elements, revealing the true architecture of the forest. Without the distraction of green foliage, you can see the honest bones of the woodland, the way branches reach toward light, how trunks twist and lean in their centuries-long dance with wind and weather. In these quiet months, deciduous trees enter what scientists call dormancy. But this isn't sleep as we know it. It's more like a state of patient waiting, a conscious slowing down that allows them to survive temperatures that would kill them in their growing season. Their sap thickens and moves downward, carrying sugars and nutrients to the roots where they'll be stored safely below the frost line. Cell walls strengthen with special proteins that act like natural antifreeze, preventing the deadly ice crystals from forming that could tear apart living tissue. The maple trees stand with particular grace in winter, their bark darkening to deep charcoal against the white snow. These giants can live for several centuries, and each ring in their trunk tells a story of seasons survived, storms weathered, and springs celebrated. In the depths of winter, they're already preparing for the sweet sap runs that will come with the first warm days of late winter, when temperature swings between freezing nights and mild days, create the pressure changes that push their lifeblood upward once again. Oak trees, those ancient symbols of strength and endurance, take a different approach to winter survival. Many species hold onto their brown leaves throughout the coldest months, a phenomenon called marcescence. Walking through an oak grove in January, you'll hear the gentle rustle of these persistent leaves, a soft percussion that accompanies your footsteps. Scientists believe this leaf retention may help protect developing buds from harsh winter weather. Or perhaps it's simply an evolutionary quirk that serves no current purpose but causes no harm. Evergreen conifers paint a different picture entirely in the winter landscape. Their needle-shaped leaves are marvels of cold weather engineering, with waxy coatings that prevent moisture loss and narrow surfaces that shed snow efficiently. Pine, spruce, fir, and hemlock trees continue their quiet photosynthesis even in the coldest months, though at a much slower pace than their summer efforts. Their dark green presence provides crucial shelter for wildlife and creates those cathedral-like spaces beneath their boughs where snow rarely penetrates and the air feels warmer and more protected. The white pine, with its soft clusters of long needles, creates some of the most peaceful groves in the winter forest. These trees can live for centuries, growing slowly but steadily, their trunks eventually reaching impressive diameters. Native Americans called the white pine the tree of peace, and walking among these gentle giants on a snowy day, it's easy to understand why. Their branches layer in perfect whorls, creating natural terraces that catch snow in graceful horizontal lines, turning each tree into a living sculpture. Beneath the snow, the forest floor tells its own winter story. What appears to be lifeless ground is actually teeming with activity, just slowed to winter's patient pace. Decomposer organisms continue their vital work, breaking down fallen leaves and branches at a rate perfectly matched to the cold. This slow decay releases nutrients gradually, feeding the soil community that will support explosive spring growth when warmth returns. Small mammals create invisible highways beneath the snow, tunnels and passages that connect burrows, food caches, and favorite foraging spots. Voles and shrews live in this sub-Nivean world, insulated from the harsh surface conditions by the snow's natural insulation properties. Their tiny heartbeats and quick movements add a hidden pulse to the seemingly still forest. A reminder that life finds ways to continue even in the depths of winter. The silence of winter woods is not empty but full, layered with subtle sounds that reward careful listening. The distant call of a crow echoes differently in cold air, carrying farther and with greater clarity than in the dense atmosphere of summer. Wind moves through bare branches with a different voice than it carries through leaves, creating haunting melodies that seem to speak of time and endurance and the patient turning of seasons. Snow transforms everything it touches, softening harsh edges and creating gentle curves where angular branches once defined sharp lines against the sky. It accumulates in the crooks of branches, builds pillowy caps on fence posts, and creates smooth drifts that flow like frozen waves between the trees. Each snowflake that falls is unique, a tiny crystal masterpiece that joins billions of others to create this winter wonderland, this temporary transformation that will melt away with spring's return, but for now defines the character of the sleeping forest. Animal tracks in fresh snow tell stories of nocturnal adventures and daily survival routines. The delicate prints of a fox weave between trees, following scent trails invisible to human senses. Deer hooves leave deep impressions where herds have passed, their paths worn into regular highways that connect feeding areas with sheltered bedding spots. Even the smallest creatures leave their marks, from the tiny handprints of raccoons to the dragging tail marks of opossums, creating a library of wilderness activity written fresh each morning in the snow. Winter birds add flashes of life and color to the monochrome landscape. Cardinals, brilliant red against white snow, seem like living ornaments decorating the bare branches. Blue jays call raucously from high perches, their voices carrying clearly in the crisp air. Chickadees move in busy flocks, their acrobatic feeding performances on seed-bearing plants, providing entertainment for any observer patient enough to stand quietly and watch. These year-round residents have adapted to cold weather living, fluffing their feathers for insulation and finding shelter in tree hollows and thick evergreen groves when temperatures drop to dangerous levels. The winter forest teaches lessons about patience and adaptation that our hurried world often forgets. Trees that have stood for decades or centuries show us what it means to endure, to bend without breaking, to find ways to thrive even in difficult conditions. They demonstrate the wisdom of seasonal rest, of pulling energy inward during harsh times and trusting that better conditions will return. Their winter dormancy isn't defeat, but strategy, a conscious choice to preserve resources for the explosive growth that spring will demand. Ice forms its own artistry in the winter woods, coating bare branches with crystal sleeves that turn ordinary trees into fairy tale sculptures. When sunlight hits these ice-covered surfaces, the forest glitters and sparkles like a world made of diamonds. Stream edges freeze in fantastic formations, with icicles hanging like organ pipes from overhanging banks and ice shelves extending out over still-flowing water beneath. These frozen decorations are temporary masterpieces, lasting only until the next warm day, or strong wind brings them crashing down in tinkling cascades. The quality of light changes dramatically in winter forests, filtered through bare branches instead of dense leaves, creating patterns of shadow and brightness that shift throughout the short days. Snow reflects and amplifies available light, making even overcast days brighter than they would be in summer woods. Sunset and sunrise paint the white landscape in shades of pink and gold, colors that seem more intense against the stark backdrop of winter trees and pristine snow. Human beings have always found something spiritually nourishing about winter forests. perhaps because they strip away the distractions of abundant life and leave us face to face with the essential elements of existence. Many cultures have traditions of winter forest walks, meditation practices that use the quiet season as a time for inner reflection and renewal. The Japanese practice of forest bathing, or shinrin-yoku, takes on a different character in winter, when the forest's reduced activity creates space for deeper contemplation and connection with the natural rhythms that govern all life. As we walk deeper into these winter woods, stepping carefully on the packed snow trail that winds between sleeping trees, we begin to understand that this season of apparent death is actually a season of profound rest and preparation. Every tree, every shrub, every dormant wildflower root is engaged in the essential work of survival and renewal, storing energy and resources that will fuel the miraculous explosion of life that defines spring in the temperate forest. The winter forest invites us to match its pace, to slow our breathing and quiet our minds, to appreciate the subtle beauties that reveal themselves only to patient observers. In a world that never seems to sleep, these woods offer a different way of being, a reminder that rest is not laziness but wisdom, that sometimes the most important work happens in stillness and silence. The deeper we venture into these winter woods, the more we notice how sound travels differently through the cold, still air. Each footstep seems amplified, yet somehow muffled by the snow's soft embrace. The crunch of our boots creates a rhythm that matches the forest's unhurried heartbeat, a gentle percussion that doesn't disturb the peace, but adds to it, like a quiet drum keeping time with the season's slow dance. Here, where ancient hemlocks create natural cathedrals with their drooping branches heavy with snow, we discover that winter forests are master architects of shelter. These evergreen giants understand the art of protection, their lower branches sweeping almost to the ground, creating dry spaces beneath where smaller creatures find refuge from wind and weather. The air under these natural umbrellas feels warmer, charged with the subtle fragrance of resin and the earthy scent of protected soil. Between the hemlock groves, open meadows stretch like frozen lakes, their summer wildflowers now sleeping beneath blankets of white. These clearings serve as natural gathering places for wildlife, where deer emerge at dawn and dusk to pore through snow in search of dried grasses and fallen seeds. Their breath creates small clouds in the frigid air, visible reminders that life continues its essential functions, even when the world appears locked in ice. The beech trees stand out dramatically in winter landscapes, their smooth grey bark almost luminous against the white snow. Many retain their pale bronze leaves through the coldest months, creating a gentle rustling soundtrack when winter breezes pass through their branches. These persistent leaves catch snow in delicate layers, building up until the weight becomes too much, and small avalanches cascade down, leaving brief sparkles of disturbed crystals settling back into stillness. Water takes on magical properties in the winter forest, transforming from the flowing streams and babbling brooks of warmer seasons into sculptures of ice and snow. Where creeks once gurgled over rocks, now frozen waterfalls hang suspended in time, their cascade patterns preserved in crystal clarity. Some streams continue flowing beneath thin ice, creating mysterious sounds that seem to come from the earth itself, underground melodies that speak of persistence and the unstoppable nature of water's journey toward the sea. Winter reveals the forest's hidden architecture in ways that other seasons conceal. Without leaves to obscure the view, we can see how trees have grown in response to their neighbors, how they've reached for gaps of sunlight, how they've adapted their shape to wind patterns and available space. Some trunks lean at dramatic angles, supported by their neighbors in a silent community of mutual assistance that has lasted decades. Others grow in perfect spirals, twisted by prevailing winds into living sculptures that demonstrate nature's ability to create art through simple persistence. The wildlife that remains active during winter months displays remarkable adaptations that speak to the ingenuity of natural selection. Squirrels, their coats now thick and luxurious, have spent autumn months creating elaborate caching systems, burying nuts and seeds in hundreds of locations throughout their territory. Their winter behavior becomes a fascinating treasure hunt as they remember and relocate these hidden stores with remarkable accuracy, digging through snow to reach food supplies buried months earlier. Ravens and crows, highly intelligent members of the winter forest community, demonstrate complex social behaviors that become more visible against the simplified winter backdrop. They communicate with a vocabulary of calls that seems to carry specific meanings, coordinating group activities and sharing information about food sources and potential dangers. Their black forms stand out dramatically against white snow, and their presence adds a sense of watchful intelligence to the winter woods, as if the forest has eyes that observe and remember everything that passes through. The phenomenon of winter trees creaking and groaning in cold weather creates an almost musical backdrop to forest walks. These sounds, often described as the forest's winter song, occur when temperature changes cause wood to expand and contract, creating internal stresses that release as audible pops, cracks, and deep groans. Far from being signs of distress, these sounds indicate healthy trees responding normally to their environment, adding their voices to winter's unique symphony. Frost creates temporary art installations throughout the winter forest, painting delicate patterns on everything it touches. Spiderwebs become visible masterpieces when outlined in crystal, revealing the intricate engineering that usually goes unnoticed. Fallen logs develop coatings of hoarfrost that transform rough bark into surfaces that look carved from the finest lace. These frost decorations last only until the sun's rays touch them, making each discovery a fleeting gift for early morning walkers. The interplay between wind and snow creates constantly changing sculptures throughout the winter forest. Snow drifts build up against fallen logs and large rocks, creating smooth, flowing forms that look like abstract art installations. Wind carves these drifts into fantastic shapes, sometimes creating natural snow caves and tunnels that provide shelter for small animals. The patterns change with each storm, ensuring that no two visits to the winter forest ever reveal exactly the same landscape. Tracking becomes an essential skill for truly understanding winter forest life, as the snow serves as a perfect canvas for recording the activities of all forest inhabitants. Learning to read these stories written in tracks and sign opens up a hidden world of drama and daily survival. The purposeful straight line of a fox on a hunting mission looks completely different from the wandering meanders of the same animal when simply exploring its territory. Rabbit tracks show the characteristic four-print pattern of hopping locomotion, often ending abruptly at the base of thick bushes where safety awaits. The scents of winter forests differ dramatically from those of other seasons, with cold air carrying odors differently, and plant fragrances reduced to their most essential elements. The sharp, clean smell of snow itself becomes familiar, along with the resinous perfumes of evergreen trees and the earthy undertones of frozen soil. Occasionally, wood smoke from distant cabins drifts through the trees, adding a note of human presence that somehow enhances rather than detracts from the wilderness experience. Winter storms transform the forest into a dynamic theatre where natural forces play out dramatic performances. Heavy snows bend branches to their breaking points, creating natural pruning events that help trees maintain their health and structure. Ice storms coat everything in crystalline armor, turning the forest into a glittering wonderland, while demonstrating the incredible weight that water can add to tree branches. The aftermath of these storms reveals the forest's resilience, as trees shed their ice burdens and straighten their storm-bent branches with remarkable recovery abilities. The silence of deep winter woods becomes a meditation in itself, broken only by the subtle sounds that reward careful listening. The distant drumming of a woodpecker echoes through the trees as these specialized birds search for insect larvae hidden beneath bark. The soft whisper of snow sliding off pine needles creates gentle percussion, while the almost inaudible breathing of the forest itself can be detected by those who stand perfectly still and open their senses completely. Photography in winter forests presents unique challenges and rewards. as the high contrast between dark tree trunks and white snow creates dramatic compositions. The simplified color palette forces attention to texture, form, and the subtle variations in tone that distinguish different types of bark, snow conditions, and ice formations. Early morning and late afternoon light takes on special qualities when filtered through bare branches and reflected off snow surfaces, creating opportunities for capturing the ethereal beauty that defines winter woodland scenes. As we continue our gentle exploration through these transformed woods, we begin to understand that winter forests offer lessons in minimalism and the beauty of essential forms. Stripped of summer's abundant decorations, the woodland reveals its fundamental structures and relationships, teaching us to appreciate subtlety and to find richness in simplicity. Each bare branch against the sky becomes a calligraphy stroke, each snow-covered boulder a meditation on form and substance. Hue. The winter forest reminds us that rest and renewal are not empty spaces in life's calendar, but essential periods of preparation and gathering strength. Like the sleeping trees around us, we too need seasons of quieter activity, times when growth happens internally and energy is conserved for future endeavors. In the patient example of these winter woods, we find permission to embrace our own need for stillness and reflection, understanding that dormancy is not defeat, but wisdom distilled into its most essential form. The deeper territories of winter forests reveal themselves only to those willing to venture beyond the well-traveled paths. Here, where human footsteps rarely disturb the pristine snow, we discover how the woodland creates its own microenvironments, each one a carefully balanced ecosystem operating according to winter's particular rules. Ancient groves of sugar maples create natural windbreaks, their massive trunks channeling air currents and creating calmer zones where smaller trees find protection from the season's harsher elements. In these sheltered pockets, we find evidence of the forest's remarkable ability to self-regulate and maintain stability even during the most challenging months. Fallen logs, now covered in thick blankets of snow, continue their slow transformation into soil, hosting communities of fungi and bacteria that work tirelessly despite the cold. These decomposing giants serve as nurse logs, providing nutrients and growing medium for the next generation of forest inhabitants, demonstrating how death becomes the foundation for new life in nature's endless cycle. The various species of birch trees scattered throughout these woods display their own unique adaptations to winter survival. Paper birch, with its distinctive white bark marked by horizontal black lines, has evolved this pale coloration partly as protection against temperature extremes. The light-colored bark reflects intense winter sunlight that might otherwise heat the trunk too rapidly on warm days, preventing the dangerous freeze-thaw cycles that could damage the tree's internal structure. Yellow birch trees tell different stories through their winter appearance, their golden bark peeling in thin, papery strips that curl away from the trunk like ancient scrolls. These trees often grow from what foresters call nurse logs, their roots eventually growing around and over the decaying wood that gave them life. In winter, when the nurse log has completely decomposed, these birches appear to stand on stilted roots, creating natural archways and tunnels that add architectural interest to the winter landscape. The forest's edge zones, where woodland meets meadow or clearing, create some of the most dynamic winter environments. Here, wind patterns become more complex, creating drifts and sculpted snow formations that change dramatically with each weather event. These transition areas often support different plant communities, with hardy shrubs and smaller trees that can tolerate more exposure to wind and temperature fluctuations. Winterberry bushes dot these edge environments with brilliant red berries that persist long after their leaves have fallen, creating focal points of color that attract both wildlife and human attention. These native holly relatives have evolved to time their fruit production perfectly, providing crucial winter food sources when other options become scarce. Their berries contain enough fat and carbohydrates to sustain migrating and resident birds through the coldest months. The phenomenon of snow loading creates constantly changing sculptures throughout the winter forest, as accumulating snow tests the structural limits of every branch and twig. Some trees, like the flexible willows and birches, bend gracefully under snow's weight, their branches forming elegant arcs that spring back when the load becomes too heavy. Others, particularly evergreens with dense needle coverage, develop their own snow-shedding strategies, dropping loads at strategic intervals to prevent breakage. Winter reveals the forest's water systems in ways impossible during other seasons. Springs that bubble up from underground sources create areas of green moss and unfrozen water that seem miraculous against the frozen landscape. These thermal features support their own microclimates, where temperatures remain relatively stable, and small communities of specialized plants can survive throughout the coldest months. Wetland areas within the forest take on ethereal qualities during winter, with cattail marshes transformed into forests of brown stalks rising from ice and snow. These frozen wetlands serve as highways for wildlife, providing firm footing across areas that would be impassable during warmer months. The seed heads of various wetland plants, now dried and architectural, create striking silhouettes against winter skies, while continuing to provide food for seed-eating birds and small mammals. The intricate relationship between snow depth and forest ecology becomes apparent as we observe how different areas accumulate and retain snow cover. North-facing slopes, protected from direct sunlight, maintain deeper snowpacks that provide better insulation for dormant plants and hibernating animals. South-facing slopes experience more frequent freeze-thaw cycles, creating different conditions that favor different species and survival strategies. Coniferous forests create their own unique winter environments, with dense canopies that intercept much of the falling snow, creating relatively dry conditions beneath the trees. These areas become crucial wildlife habitat during severe weather, offering shelter and easier movement for animals that might struggle in deeper snow. The carpet of fallen needles beneath these trees provides insulation and continues to decompose slowly, maintaining soil temperatures that support underground biological activity. The winter forest's ability to create and maintain diverse habitats within a seemingly uniform landscape demonstrates nature's incredible efficiency in resource utilization. Every microenvironment serves multiple functions, from providing shelter and food for wildlife to maintaining soil health and water quality. Dead standing trees, called snags, become apartment buildings for cavity-nesting birds and mammals, while also serving as foraging sites for insect-eating species. Wind patterns in winter forests create an invisible architecture that influences everything from snow distribution to seed dispersal. Tall trees channel air currents, creating wind tunnels in some areas and calm zones in others. Understanding these patterns helps explain why certain areas consistently develop deeper snowdrifts, while others remain relatively clear, and why some trees lean in particular directions or develop asymmetrical growth patterns. The acoustic properties of winter forests change not only because of reduced biological activity, but also due to the physical properties of cold, dry air and snow-covered surfaces. Sound travels differently through these conditions, with some frequencies carrying farther, while others become muffled. The creak and groan of trees adjusting to temperature changes creates a unique soundscape that many people find deeply calming and meditative. Animal adaptations to winter forest life demonstrate remarkable evolutionary solutions to seasonal challenges. Snowshoe hares develop oversized feet that function like natural snowshoes, allowing them to travel across snow surfaces that would trap other animals. Their seasonal color change from brown to white provides camouflage against predators, while their ability to survive on a diet of bark and twigs allows them to find food even when other options disappear. The role of winter forests in carbon sequestration continues even during the coldest months, though at reduced rates. Trees maintain their carbon storage in woody tissues, while continuing slow photosynthesis on warmer days. The reduced decomposition rates of winter mean that carbon stored in fallen leaves and organic matter remains locked in the soil longer, contributing to the forest's role as a carbon sink that helps mitigate climate change effects. Mycorrhizal networks, the fungal partnerships that connect tree roots throughout the forest, remain active beneath the snow, maintaining the communication and resource-sharing systems that help forests function as integrated communities. These underground networks continue to transport nutrients and chemical signals between trees, ensuring that the forest community remains connected even when above-ground activity slows dramatically. The winter forest serves as a natural laboratory for understanding plant and animal adaptations to extreme conditions. Every survival strategy visible in these woods represents millions of years of evolutionary refinement, from the antifreeze proteins in tree cells to the behavioral adaptations that allow animals to find food and shelter in harsh conditions. These adaptations provide insights that scientists apply to human challenges, from developing better cold weather materials to understanding how organisms cope with stress. Ice formations in winter forests create temporary architectural features that rival human artistic achievements. Frozen waterfalls become crystalline sculptures, while ice-covered streams create natural bridges and tunnels. These formations constantly change as temperatures fluctuate, ensuring that each visit to the winter forest reveals new ice artistry. The way ice interacts with flowing water creates patterns and textures that seem almost deliberately designed for aesthetic impact. The medicinal and practical uses of winter forest resources have sustained human communities for thousands of years. Many trees produce their most concentrated medicinal compounds during winter months, when they're storing resources and producing protective chemicals. Traditional knowledge about harvesting and using these winter forest products represents a deep understanding of seasonal cycles and plant biology that modern science continues to validate and explore. Winter forest ecosystems demonstrate remarkable resilience and adaptability in the face of environmental challenges. The same mechanisms that allow these forests to survive harsh winter conditions also help them adapt to other stresses, from drought to disease outbreaks. This resilience makes winter forests valuable models for understanding how natural systems maintain stability while continuing to function under difficult conditions. The spiritual and psychological benefits of spending time in winter forests have been recognized across many cultures and throughout history. The combination of simplified landscapes, clean air, and peaceful soundscapes creates conditions that naturally promote relaxation and contemplation. Modern research confirms what traditional wisdom has long recognized. Time spent in natural environments, particularly forests, provides measurable benefits for mental health and stress reduction. As we walk these quiet paths between snow-laden trees, we become part of an ancient human tradition of finding solace and wisdom in winter woods. The forest offers lessons in patience, adaptation, and the beauty of seasonal rhythms that our modern world often obscures. Each step deeper into these peaceful groves connects us more fully with the natural cycles that govern all life, reminding us of our place within the larger community of living beings that share this remarkable planet. The winter forest teaches us that beauty exists in every season, though it may require different eyes to perceive it. Where summer offers abundance and autumn provides spectacular color, winter presents the elegant beauty of essential forms revealed, of life distilled to its most fundamental expressions. In learning to appreciate winter's subtle artistry, we develop a deeper capacity for finding meaning and beauty in all of life's seasons, both in nature and within ourselves. The relationship between winter forests and the creatures that call them home extends far beyond simple survival strategies. These woodlands become stages for complex dramas of adaptation and cooperation that unfold slowly throughout the coldest months. Porcupines, those spiny ambassadors of winter resilience, demonstrate remarkable climbing abilities as they ascend high into trees to reach nutritious inner bark. Their feeding signs become visible throughout winter woods, distinctive patches where bark has been methodically stripped away, revealing the pale wood beneath like abstract paintings created by hunger and persistence. Red squirrels maintain their territorial boundaries even in the depths of winter, their chattering calls echoing through the forest as they defend cone caches and nesting sites. These energetic creatures create middens beneath favorite feeding trees, accumulating piles of cone scales and cores that can grow several feet high over multiple seasons. These refuse heaps become archaeological records of winter dining, telling stories of good cone years and lean times, of successful preparation and seasonal abundance. The great horned owls that hunt these winter forests represent apex predators perfectly adapted to cold weather conditions. Their thick feather coats extend even to their feet, creating natural snowshoes that allow silent movement across winter terrain. Their hunting calls pierce the night air with haunting authority, deep hoots that carry for miles through the still, cold atmosphere. These magnificent birds raise their young during the harshest months, timing their reproduction so that hungry owlets coincide with spring's abundance of small mammals. Winter moths, those unlikely cold season insects, emerge during warm spells to mate and lay eggs on bare tree branches. Their presence seems miraculous in a season when most insects have long since died or entered dormancy. These hardy creatures have evolved antifreeze compounds in their body fluids, allowing them to remain active at temperatures that would be lethal to their summer relatives. Their brief flights add unexpected movement to the winter forest, tiny dancers performing against the backdrop of snow and bare branches. The forest's understory takes on completely different characteristics during winter months, with shrubs and small trees creating intricate patterns of brown and grey stems against white snow. Elderberry bushes display their winter architecture, multiple stems rising from common root systems in graceful clusters that demonstrate how these plants maximize their growing space. Their dried flower heads, now empty umbels, catch snow in delicate patterns that highlight the mathematical precision of their branching structures. Dogwood species scattered throughout the winter forest provide splashes of color through their brilliant red and yellow bark, adaptations that help them photosynthesize even during leafless months. These colorful stems stand out dramatically against snow, creating natural bouquets that brighten the shortest days of the year. The contrast between their vibrant bark and the monochrome winter landscape demonstrates how plants have evolved multiple strategies for making the most of limited growing seasons. Stream corridors through winter forests become highways of activity, as flowing water creates ice-free zones that concentrate wildlife activity. These riparian areas support different microclimates, with temperatures moderated by flowing water and humidity levels that remain higher than in surrounding uplands. Watercress and other cold-hardy plants continue growing in these protected zones, providing fresh green food sources when most vegetation lies dormant beneath snow. The geological features of winter forests become much more apparent when vegetation dies back and snow accumulates in distinctive patterns. Rock outcroppings emerge as dramatic landscape elements, their surfaces decorated with ice formations and snow sculptures that change daily with weather patterns. These stone features provide crucial wildlife habitat, offering den sites for small mammals and roosting spots for birds seeking shelter from wind and precipitation. Ancient stone walls, remnants of long-abandoned farms, create linear features that guide both wildlife movement and snow accumulation patterns throughout winter forests. These historical artifacts demonstrate how human land use has shaped current forest structure, with the stones now serving as foundations for different plant communities and wildlife corridors. Moss and lichen communities thrive on these walls, creating miniature ecosystems that add biodiversity to the winter woodland. The phenomenon of tree wells, the circular depressions that form around large tree trunks as snow accumulates, creates unique microhabitats within the winter forest. These wells form because heat radiating from tree trunks causes nearby snow to settle and compact differently than snow in open areas. Small mammals use these wells as travel routes and feeding areas, taking advantage of the easier movement they provide through otherwise deep snow. Witch hazel bushes provide one of winter's most unexpected floral displays, blooming with spidery yellow flowers even as snow falls around them. These remarkable shrubs have evolved to flower during the coldest months, when most other plants lie completely dormant. Their blooming strategy takes advantage of reduced competition for pollinators, with specialized insects that remain active during winter warm spells, providing pollination services that ensure seed production. The intricate ice patterns that form on shallow woodland pools create temporary art installations that rival the finest glass sculpture. These formations develop as water freezes in layers, with each freeze-thaw cycle adding new elements to increasingly complex designs. Bubbles trapped in ice create three-dimensional sculptures, while leaves frozen into ice surfaces create natural stained glass windows that glow when backlit by winter sun. Winter forest edges where woods meet agricultural fields create ecotone environments that support unique wildlife communities. These transition zones often accumulate deeper snow due to wind patterns, while also providing access to different food sources as agricultural residues become available under snow cover. Field mice and voles create extensive tunnel systems in these areas, connecting forest shelter with field feeding opportunities. The role of winter forests in watershed protection becomes particularly apparent during spring melt periods, when the gradual release of stored snow and ice helps regulate stream flow and prevent flooding in downstream areas. The forest canopy and organic forest floor act as natural retention systems, slowing snowmelt and allowing gradual infiltration that recharges groundwater supplies essential for year-round stream flow. Maple syrup production represents one of the most iconic interactions between humans and winter forests, demonstrating how traditional knowledge has learned to work with natural seasonal rhythms. The freeze-thaw cycles of late winter create the pressure differences that drive sap flow, while the tree's stored starches convert to sugars that make the sap sweet and valuable. This ancient practice connects modern people with seasonal cycles that have governed forest life for millennia. Winter tracking reveals the complex social structures of forest wildlife, as pack animals leave group signatures in snow, while solitary species demonstrate individual movement patterns and territorial boundaries. Coyote families travel together, their tracks showing how they coordinate hunting strategies and share parental duties. Fisher tracks reveal the tree-to-tree movement patterns of these skilled climbers as they hunt for porcupines and other arboreal prey. The medicinal plants that remain accessible during winter months represent crucial knowledge preserved by indigenous peoples and traditional healers throughout northern regions. Birch bark contains compounds that reduce inflammation and pain, while pine needles provide vitamin C that prevented scurvy during long winters. These plant medicines demonstrate how winter forests have always provided essential resources for human survival and health. Snow crystal formation in forest environments creates countless variations on the basic snowflake theme, with local humidity, temperature, and air movement patterns influencing the development of each individual crystal. The different types of snow that accumulate throughout winter create layered records of weather events, with each storm leaving distinctive signatures that experienced woodsmen can read like pages in a meteorological diary. The winter forest floor beneath deep snow becomes a protected zone where decomposition continues at slow but steady rates, with specialized bacteria and fungi adapted to cold conditions, maintaining the nutrient cycling processes essential for forest health. This hidden biological activity ensures that when spring arrives, the soil will be rich and ready to support the explosive growth that characterizes the forest's awakening from winter dormancy. Evergreen trees demonstrate different snow-loading strategies based on their evolutionary histories and geographic adaptations. Spruces shed snow regularly through branch flexibility, while firs tend to hold snow loads longer, using the insulation properties to protect their needles from desiccation during cold, windy periods. These different approaches reflect the diverse solutions that evolution has developed for surviving winter conditions. The acoustic ecology of winter forests includes not only the sounds that are present, but also the sounds that are absent, creating a sensory experience dramatically different from other seasons. The lack of insect buzzing, bird songs, and rustling leaves create space for subtler sounds to emerge, from the creaking of wood fibers adjusting to cold, to the whispered conversations of wind moving through different types of vegetation. Winter forest photography captures not just visual beauty, but also the emotional resonance of seasonal transition, with the interplay of light, shadow, and texture creating images that speak to universal human experiences of change, endurance, and renewal. The simplified compositions possible in winter landscapes focus attention on fundamental design elements, teaching lessons about the power of minimalism and the beauty inherent in essential forms. Traditional winter forest crafts utilize the specialized properties of cold season materials, from the straight grain of winter-cut lumber to the medicinal potency of bark harvested during dormant seasons. These practices required intimate knowledge of seasonal changes in wood and plant chemistry, representing sophisticated understanding of how winter affects the properties of forest resources. The spiritual traditions associated with winter forests across many cultures recognize these environments as places of purification and renewal, where the stripping away of summer's abundance creates opportunities for deeper reflection and connection with essential life forces. The silence and simplicity of winter woods naturally promote meditative states, making them ideal settings for contemplative practices and personal transformation. Wildlife corridors become particularly important during winter months as animals concentrate their activities in areas that provide both food and shelter resources. These natural highways allow genetic exchange between populations while also providing escape routes during severe weather events. The connectivity of winter habitats often determines the survival success of wildlife populations throughout entire regions. The ethnobotany of winter forests includes not only food and medicine, but also the materials for shelter, tools, and clothing that enabled human communities to thrive in cold climates. Birch bark for containers, pine pitch for waterproofing, and various plant fibers for cordage represent just a few examples of how winter forests provided technological solutions for seasonal survival challenges. Climate change impacts on winter forest ecosystems create new patterns of seasonal behavior, with shorter winters and more frequent freeze-thaw cycles affecting everything from maple syrup production to wildlife migration timing. These changes demonstrate how interconnected forest communities respond to environmental shifts, with effects cascading through multiple species relationships and ecosystem functions. The winter forest serves as a living library of adaptation strategies, with each species representing millions of years of evolutionary problem-solving focused on seasonal survival challenges. From behavioral adaptations like food caching to physiological changes like antifreeze protein production, these woods showcase the incredible diversity of solutions that life has developed for thriving in challenging environments. Forest succession patterns become particularly visible during winter months, when the different growth stages and species compositions of various forest stands create distinctive landscape patterns. Young forests with dense small trees look completely different from mature stands with widely spaced large trunks, demonstrating how forest communities change over time and how disturbance events shape long-term forest development. The integration of winter forest ecosystems with human communities represents both historical relationships that sustain traditional cultures and modern opportunities for sustainable resource management that benefits both people and wildlife. Understanding these relationships helps inform current conservation strategies and forest management practices that support both ecological health and human community needs. Winter forest restoration projects focus on re-establishing the natural processes and species relationships that create resilient forest communities capable of surviving seasonal extremes and adapting to changing environmental conditions. These efforts often involve removing invasive species, reintroducing native plants, and restoring natural disturbance patterns that maintain forest diversity and health. The winter forest stands as testament to life's remarkable ability to find solutions to seemingly impossible challenges, demonstrating through countless adaptations and relationships how communities of living beings can not only survive, but thrive in conditions that test every aspect of their biological capabilities. These woods remind us that resilience comes not from avoiding difficulty, but from developing the flexibility and cooperation necessary to work with natural rhythms and seasonal changes. As we move deeper into these quiet winter sanctuaries, we discover that each grove and glade holds its own particular character, shaped by subtle differences in soil, drainage, exposure, and history. The winter forest reveals itself not as a uniform landscape, but as a complex mosaic of microenvironments, each supporting its own community of specially adapted organisms that have found ways to call this challenging season home. Home. In the deepest hollows of these winter woods, where cold air settles and snow accumulates in thick, undisturbed layers, we encounter the forest's most protected sanctuaries. These natural basins create their own weather patterns, with temperatures that remain more stable than the surrounding hillsides and humidity levels that support unique communities of cold-adapted mosses and lichens. The silence here feels almost tangible, as if the very air has thickened with winter's patience, creating spaces where time seems to slow to match the rhythm of sleeping sap and dormant roots. The sugar maple groves that crown the gentle ridges display their winter majesty through the elegant architecture of their bare branches. These trees, some approaching their second or third century of life, have developed crown structures that speak of decades spent reaching toward optimal light. Their bark, deeply furrowed and darkly beautiful, tells stories of storms weathered and seasons endured. In late winter, as daylight hours begin to lengthen almost imperceptibly, these giants begin the subtle preparations for sap flow that will mark the first stirrings towards spring. Ancient white oaks scattered throughout these woods stand as monuments to persistence, their massive trunks bearing the scars and character marks of centuries lived fully. These trees can survive for 800 years or more, making them some of the oldest living residents of temperate forests. Their winter silhouettes reveal the complex branching patterns that develop over such extended lifespans, with each major limb representing decades of growth decisions made in response to changing light conditions, competition with neighbors, and recovery from storm damage. The American chestnut stumps that occasionally appear along old ridgeline paths remind us of the forest's capacity for both loss and recovery. These remnants of once mighty trees, now reduced to persistent root systems that send up hopeful shoots each spring, demonstrate how ecosystems adapt to catastrophic change. The chestnut blight that swept through eastern forests in the early 20th century created openings that other species filled, reshaping forest composition in ways that continue to influence current woodland communities. Basswood trees, with their heart-shaped leaf scars visible on bare winter twigs, create some of the most graceful winter silhouettes in the deciduous forest. These trees, also called American linden, develop smooth, pale grey bark that almost seems to glow in winter light. Their inner bark has provided fibre for cordage and basketry for countless generations of indigenous peoples, demonstrating how winter forests have always offered resources for human communities that understood seasonal cycles and sustainable harvesting practices. The ironwood trees, also known as hop hornbeam, display some of the most interesting bark patterns in the winter forest, with thin strips that peel away in vertical ribbons, creating textured surfaces that catch and hold snow in intricate patterns. These understory trees rarely grow large, but their incredibly hard, dense wood has made them valuable for tool handles and other applications requiring durability. Their winter buds, small but perfectly formed, demonstrate the precise engineering that allows deciduous trees to protect next year's growth through months of freezing temperatures. Stream valleys cutting through winter forests create ribbon-like ecosystems that support different plant communities than the surrounding uplands. These riparian zones remain slightly warmer due to flowing water and often support remnant populations of plants more common in southern regions. Spicebush, with its aromatic twigs that release lemony scents when broken, thrives in these protected valleys, providing important early-season food sources for migrating birds when its yellow flowers bloom before most other plants have awakened. The hemlock groves that occupy cool, north-facing slopes create cathedral-like spaces beneath their evergreen canopies, where the forest floor remains relatively free of snow and the air carries the clean, resinous fragrance of these ancient conifers. Eastern hemlocks can live for centuries, growing slowly but steadily in the deep shade they create beneath their own branches. These trees serve as keystone species in their ecosystems, creating unique habitat conditions that support specialized communities of plants and animals found nowhere else in the forest. Black cherry trees scattered throughout the winter woods display their distinctive bark patterns, with dark plates separated by lighter furrows that create natural camouflage patterns. These trees produce some of the most valuable lumber in eastern forests, but they also serve crucial ecological roles as wildlife food sources. Their bark contains compounds that have been used medicinally for respiratory ailments, while their fruit supports numerous bird species during late summer and early fall. The yellow birch trees that grow from old nurse logs create some of the most photogenic features in winter forests, their golden bark peeling in thin, papery curls that curl away from the trunk like nature's own decorative ribbons. These trees often develop distinctive root systems that grow over and around the decaying logs that gave them their start, creating natural arches and sculptural forms that add architectural interest to woodland walks. Witch hazel shrubs provide winter's most surprising floral display, with their spidery yellow blooms appearing even as snow falls around them. These remarkable plants have evolved to flower during the coldest months, taking advantage of reduced competition for the few insects that remain active during winter warm spells. Their blooming represents one of nature's most optimistic gestures, a declaration that life continues even in the depths of winter's apparent dormancy. The understory shrubs that create the forest's middle layer take on entirely different characteristics during winter months, with their branching patterns revealed and their winter buds positioned like tiny promises of spring's eventual return. Elderberry bushes display their architectural branching, while viburnums show off their distinctive opposite-branched structure. These shrubs provide crucial winter food sources through persistent berries and dried fruits that sustain resident bird populations through the coldest months. Wild grapevines, now leafless but still strong, drape between trees like natural suspension bridges, their thick, woody stems testament to years of reaching towards sunlight in the forest canopy. These vines provide important structural diversity in forest ecosystems, creating travel corridors for arboreal animals and nesting sites for birds. Their bark, with its distinctive fibrous texture, peels in long strips that have been used for basketry and other traditional crafts. The forest floor beneath winter snow becomes a hidden world of continued biological activity, where specialized decomposer organisms work at cold-adapted rates to break down fallen leaves and organic matter. This slow but steady decomposition ensures that nutrients remain available for the explosive spring growth that will follow winter's end. The layered leaf litter creates insulation that moderates soil temperatures and provides shelter for overwintering insects and other small creatures. Fallen logs in various stages of decay create nurse log systems that will support future forest generations, their slowly decomposing wood providing growing medium and nutrients for seedlings that will eventually rise to take their place in the forest canopy. These decaying giants support their own specialized communities of fungi, mosses, and small plants that depend on the unique conditions created by rotting wood. The mycorrhizal networks that connect tree roots throughout the forest remain active beneath the snow, maintaining the underground internet that allows trees to share resources and chemical communications. These fungal partnerships continue to transport nutrients and water between trees, ensuring that the forest community remains connected and cooperative even when above-ground activity has slowed to winter's patient pace. Rock formations scattered throughout winter forests become prominent landscape features when vegetation dies back and snow accumulates in distinctive patterns around stone outcroppings. These geological features provide important habitat diversity, offering den sites for small mammals, roosting spots for birds, and growing sites for specialized rock-dwelling plants like mosses and lichens that add color and texture to winter landscapes. Spring seeps and groundwater discharge areas create year-round green spaces within winter forests, where flowing water prevents freezing and supports communities of cold, hardy plants like watercress and winter-active mosses. These thermal refugia become crucial habitat during severe weather, providing both water and food sources when other resources become locked beneath ice and snow. The edge environments where forest meets field or clearing create dynamic ecotones that support unique winter wildlife communities. These transition zones often accumulate deeper snow due to wind patterns, while also providing access to different food sources as seed-bearing plants from adjacent open areas become available to forest animals. Old-growth forest remnants, where they still exist, display winter characteristics dramatically different from younger woodland stands. These ancient forests support larger trees with more complex branching patterns, greater structural diversity, and unique microclimates created by centuries of undisturbed development. Their winter silence feels deeper, their snow-covered spaces more cathedral-like than forests that have experienced recent disturbance. The winter forest serves as a masterclass in energy conservation and resource management, with every species demonstrating strategies for minimizing energy expenditure while maintaining essential life functions. From the behavioral adaptations of animals that reduce unnecessary movement to the physiological changes in plants that protect against freeze damage, these woods showcase countless solutions to the challenges of seasonal survival. Traditional ecological knowledge preserved by indigenous peoples includes sophisticated understanding of winter forest resources, from the timing of optimal bark harvest to the locations of reliable water sources during frozen months. This accumulated wisdom represents thousands of years of careful observation and sustainable interaction with winter woodland ecosystems. The acoustic environment of winter forests creates unique soundscapes that change throughout the season as weather patterns shift and wildlife activity fluctuates. The clarity of cold air allows sounds to carry farther, while snow cover dampens some frequencies while amplifying others, creating natural acoustic conditions that influence both wildlife communication and human perception of forest environments. Winter forest management practices must account for the specialized needs of cold season wildlife, while also considering how winter conditions affect tree growth, soil stability, and long-term forest health. Sustainable forestry in winter environments requires understanding how seasonal cycles influence everything from timber quality to wildlife habitat requirements. The spiritual and psychological benefits of winter forest experiences have been recognized across cultures, with many traditions incorporating winter woodland visits as important elements of seasonal rituals and personal development practices. The contemplative qualities of winter forests naturally promote introspection and connection with natural cycles that govern all life. Climate change impacts on winter forest ecosystems create new patterns of seasonal timing and species interactions, with earlier spring warming and more frequent winter thaws affecting everything from maple sap production timing to wildlife reproduction cycles. These changes demonstrate the interconnected nature of forest communities and the far-reaching effects of environmental shifts. The winter forest ecosystem serves as a living laboratory for studying adaptation, cooperation, and resilience in natural communities. Every relationship visible in these woods represents evolutionary solutions to seasonal challenges, from the partnerships between trees and fungi to the behavioral adaptations that allow animals to survive months of resource scarcity. Forest succession becomes particularly visible during winter months, when different age stands display distinctive characteristics and species compositions. Young forests dominated by fast-growing species look completely different from mature stands with widely spaced large trees, illustrating how forest communities develop and change over decades and centuries. The integration of winter forests with human communities represents both historical relationships that sustain traditional cultures and modern opportunities for sustainable resource use that benefits both people and wildlife. Understanding these relationships helps inform conservation strategies that protect forest ecosystems while meeting human community needs. Winter forest restoration efforts focus on re-establishing natural processes and species relationships that create resilient woodland communities capable of adapting to seasonal extremes and changing environmental conditions. These projects often involve removing invasive species, replanting native vegetation, and restoring natural disturbance patterns that maintain forest diversity. The medicinal properties of winter-harvested forest plants represent concentrated therapeutic compounds that plants produce during dormant seasons. Traditional healing systems have long recognized that many medicinal plants reach peak potency during winter months, when stored compounds become most concentrated in bark, roots, and other plant tissues. Snow science within forest environments reveals complex interactions between weather patterns, tree canopy structure, and ground-level snow accumulation that influence everything from wildlife habitat quality to spring flood potential. Understanding these relationships helps predict how forest ecosystems will respond to different weather patterns and climate scenarios. The winter forest stands as nature's testament to the power of patience, adaptation, and community cooperation in overcoming seemingly impossible challenges. These woods demonstrate that survival often depends not on avoiding difficulties, but on developing the flexibility and collaborative relationships necessary to work harmoniously with natural cycles and seasonal rhythms that govern all life on Earth. As our gentle exploration of these winter sanctuaries continues, we find ourselves drawn ever deeper into the quiet wisdom these ancient groves offer to those willing to slow their pace and open their senses to winter's subtle teachings. Each footstep forward reveals new layers of complexity and beauty in landscapes that reward patient observation and quiet contemplation, with insights into the fundamental principles that sustain all life through every season. The winter forest's teaching extends beyond mere survival strategies into profound lessons about the art of waiting. In these hushed groves where time moves differently, we discover that dormancy is not absence, but presence in its most concentrated form. The trees around us demonstrate that true strength often lies not in constant growth and activity, but in the wisdom of knowing when to pause, when to conserve, when to trust in cycles larger than any individual moment or season. Ancient American elms, where they still survive the challenges that have reduced their numbers, display winter architecture of breathtaking elegance. Their vase-shaped crowns create natural sculptures against winter skies, with branches that divide and subdivide in patterns that follow mathematical principles found throughout nature. These survivors carry within their cells the genetic memory of forests that once stretched unbroken across entire continents, living libraries of adaptation and endurance that have witnessed centuries of change. The serviceberry trees scattered through winter understories prepare for their role as harbingers of spring's approach. Though that awakening remains weeks or months away, their smooth grey bark and delicate branching patterns create subtle beauty that rewards close observation. These trees will be among the first to bloom when warmth returns, their white flowers appearing before most other species have begun to stir, earning them the folk name of Juneberry in regions where their fruit ripens during early summer. Aspen groves create some of the most striking winter landscapes in northern forests, their pale bark appearing almost luminous against dark evergreens and white snow. These trees, which share root systems and grow as connected colonies, demonstrate one of nature's most successful survival strategies. Their winter bark continues photosynthesis even without leaves, using specialized cells that can capture and utilize winter sunlight for energy production during the coldest months. The red maple trees that thrive in wet areas throughout eastern forests show their adaptability through their ability to prosper in diverse growing conditions. Their winter buds, bright red and perfectly formed, contain next spring's flowers in miniature, already developed and waiting for the precise temperature and daylight cues that will trigger their opening. These trees demonstrate nature's forward planning abilities, preparing for reproductive success months before growing conditions will allow it to proceed. Tulip trees, those giants of the eastern deciduous forest, display winter characteristics that reflect their unique evolutionary history as members of the magnolia family. Their distinctive four-lobed leaves have fallen, leaving behind seed structures that persist through winter, like candelabras holding dried fruits that will eventually release winged seeds to the wind. These magnificent trees can live for centuries and reach enormous sizes in protected forest settings. The American beech trees that create dense groves in rich forest soils hold on to their bronze-colored leaves throughout winter, creating rustling curtains that filter wind and catch snow in graceful layers. Young beech trees particularly retain their leaves, a phenomenon that may protect developing buds from winter damage, while also creating microhabitats that moderate temperature and humidity around the tree's base. Black walnut trees, recognizable by their deeply furrowed dark bark and distinctive branching patterns, stand as monuments to the forest's ability to produce both beauty and utility. These trees create their own growing conditions by producing compounds that inhibit the growth of competing vegetation, a chemical strategy called allelopathy that demonstrates the sophisticated ways plants compete for resources and growing space. The hickory trees scattered through winter forests display some of the most distinctive bark patterns in the woodland, with shagbark hickories literally living up to their name as long strips of bark curl away from their trunks in dramatic flourishes. These trees produce nuts that have sustained both wildlife and human communities for thousands of years. Their high fat content making them crucial food sources during lean winter months. Redbud trees, though small in stature, create important understory diversity in winter forests, with their distinctive heart-shaped leaf scars and smooth bark that ranges from grey to reddish-brown. These trees will be among the most spectacular spring bloomers, covering their bare branches with pink flowers before their leaves emerge. But for now, they wait patiently in winter dormancy. The forest's vertical structure becomes most apparent during winter months, when we can clearly see how different species occupy distinct layers from the forest floor to the canopy. Tall canopy trees, understory trees, shrub layers, and ground-level plants each create their own microenvironments and support different wildlife communities. This layered architecture maximizes the forest's ability to capture sunlight and create diverse habitat niches. Woodland streams take on magical qualities during winter, with flowing water creating ribbons of movement through otherwise still landscapes. Ice formations along stream banks create temporary sculptures that change daily with temperature fluctuations, while the sound of flowing water adds a musical element to winter's quiet symphony. These waterways remain crucial wildlife highways during winter months. The winter forest floor reveals a complex topography usually hidden by summer vegetation, with subtle ridges and depressions that influence drainage patterns, snow accumulation, and growing conditions for different plant species. These microtopographic features create habitat diversity that supports specialized plant communities and provides shelter sites for small animals during severe weather. Fallen trees in various stages of decay create horizontal elements that add structural complexity to winter forests. These wind-thrown giants provide elevated highways for small mammals, nesting sites for birds, and growing substrates for mosses, ferns, and tree seedlings. The different decay stages support different species communities, creating temporal diversity as decomposition progresses over decades. The lichen communities that thrive on tree bark and rock surfaces add subtle color and texture to winter landscapes, while demonstrating some of nature's most successful partnership strategies. These composite organisms, formed by fungi and algae working together, can survive extreme cold and drought conditions that would kill most other life forms. Their presence indicates good air quality and healthy forest conditions. Moss communities on the winter forest floor create living carpets that remain green beneath snow cover, continuing their slow but steady photosynthesis throughout the coldest months. These bryophytes play crucial roles in forest hydrology, absorbing and slowly releasing moisture while preventing soil erosion on slopes and around stream banks. The seed dispersal strategies visible in winter forests demonstrate remarkable evolutionary creativity, with different species using wind, water, and animal transport to spread their genetic material. Maple samaras lie scattered on snow surfaces, waiting for spring winds to carry them to new growing sites, while persistent berries on various shrubs provide food for animals that will carry seeds to distant locations. Winter buds throughout the forest display engineering marvels in miniature, with protective scales, waxy coatings, and specialized tissues that protect delicate growing points from months of freezing temperatures. Each bud contains next year's growth in compressed form, complete with leaves, flowers, or both, ready to expand rapidly when favorable conditions return. The root systems that remain active beneath the frozen surface continue their essential work of nutrient and water uptake, though at greatly reduced rates. These underground networks, often extending far beyond the tree canopy above, demonstrate the hidden connections that link forest communities into integrated systems capable of sharing resources and information. Tree cavities created by woodpeckers, decay, or storm damage become crucial winter habitat for numerous species that depend on these sheltered spaces for survival during the coldest months. These natural apartments provide insulation and protection that can mean the difference between life and death for cavity-dwelling birds and mammals. The phenology of winter forests involves subtle changes that mark the progression towards spring, with daylight length serving as the primary cue for trees and other plants to begin their internal preparations for the growing season. Though invisible to casual observation, these physiological changes represent the forest community's response to seasonal rhythms that have governed life cycles for millions of years. Evergreen trees demonstrate different strategies for winter photosynthesis, with some species maintaining higher activity levels, while others reduce their metabolic processes to minimal levels. These different approaches reflect evolutionary adaptations to specific climate conditions and resource availability patterns in their native ranges. The winter forest's role in carbon cycling continues throughout the coldest months, with trees maintaining their stored carbon in woody tissues, while soil organisms work at reduced rates to decompose organic matter and release nutrients back into the ecosystem. This seasonal regulation of carbon flows helps moderate atmospheric carbon dioxide levels. Wildlife corridors become particularly important during winter months, when animals may need to travel longer distances to find adequate food and shelter resources. These natural highways allow movement between habitat patches while providing cover and protection during vulnerable travel periods. The ethnobotanical heritage of winter forests includes traditional uses for numerous plant species that provided food, medicine, fiber, and other necessities for indigenous communities throughout cold regions. This accumulated knowledge represents sophisticated understanding of seasonal plant chemistry and sustainable harvesting practices. Winter forest sounds create unique acoustic environments that change throughout the season as weather patterns shift and biological activity fluctuates. The absence of summer's insect chorus and bird song creates space for subtler sounds to emerge, from the creaking of wood adjusting to temperature changes to the whisper of snow settling on branches. The psychological impacts of spending time in winter forests have been documented across many cultures, with these environments naturally promoting contemplative states and stress reduction. The simplified visual environment and peaceful soundscape create conditions that support meditation and reflection. Forest management during winter months requires specialized knowledge of how cold weather affects both tree physiology and wildlife habitat needs. Sustainable practices must account for the unique vulnerabilities and requirements of forest communities during their most challenging season. Climate change effects on winter forest ecosystems create new patterns of seasonal timing and species interactions, with warmer winters and more frequent freeze-thaw cycles affecting everything from tree health to wildlife behavior patterns. These changes demonstrate the interconnected nature of forest communities and their sensitivity to environmental shifts. The winter forest serves as a natural laboratory for studying resilience, adaptation, and community cooperation under stress. Every survival strategy visible in these woods represents evolutionary solutions to seasonal challenges, providing insights applicable to understanding how natural systems maintain stability while adapting to changing conditions. Traditional winter forest crafts utilize specialized properties of cold season materials, from the straight grain of winter-harvested lumber to the concentrated medicinal compounds found in dormant season bark and roots. These practices required intimate knowledge of how winter conditions affect the properties and qualities of forest resources. The spiritual significance of winter forests across many cultural traditions recognizes these environments as places of purification and renewal, where the stripping away of summer abundance creates opportunities for deeper connection with essential life forces. The silence and simplicity of winter woods naturally promote meditative states and personal transformation. Restoration ecology in winter forests focuses on re-establishing natural processes and species relationships that create resilient communities capable of surviving seasonal extremes while adapting to changing environmental conditions. These efforts often involve patient, long-term approaches that work with natural seasonal cycles. The winter forest stands as nature's masterpiece of patience and preparation, demonstrating through countless adaptations and relationships how life communities not only endure but flourish through the most challenging conditions. These woods remind us that true strength often lies not in constant activity, but in the wisdom of seasonal rhythms and the power of cooperative relationships that sustain all life through every season. As we continue our quiet journey through these transformed landscapes, we find ourselves increasingly attuned to the subtle rhythms and hidden activities that define winter forest life. Each moment spent in these peaceful groves deepens our appreciation for the complex relationships and remarkable adaptations that allow entire communities of living beings to thrive in conditions that test every aspect of their biological capabilities and evolutionary heritage. The winter forest teaches us that beauty and vitality exist in every season, though they may require different eyes to perceive and different hearts to fully appreciate. In learning to see winter's elegant artistry and understand its essential role in natural cycles, we develop deeper capacity for finding meaning and wonder in all of life's seasons, both in the natural world around us and within the seasonal rhythms of our own lives and experiences. The winter forest reveals its most intimate secrets to those who venture beyond the familiar pathways, where human footsteps become rare and the wilderness unfolds in its purest form. Here, in these remote sanctuaries where silence reigns supreme, we discover how the woodland creates its own protected realms, each one a carefully orchestrated environment designed by millions of years of seasonal adaptation and natural selection. Ancient groves of eastern white cedar create natural windbreaks along exposed ridges, their scale-like foliage forming dense barriers that channel winter winds and create calmer microclimates in their lee. These aromatic evergreens, sometimes called arbor vitae or tree of life, have sustained both wildlife and human communities through countless winters. Their fibrous bark peels in long strips that indigenous peoples wove into baskets and clothing, while their dense branching provides crucial shelter for small birds during the harshest weather. The towering white ash trees that punctuate these winter forests display their distinctive diamond-patterned bark and opposite branching structure with mathematical precision. These trees, now tragically threatened by invasive insects in many regions, represent one of the forest's most valuable hardwood species. Their winter buds, dark and velvety, protect next spring's compound leaves and clusters of small flowers that will appear before the leaves emerge. The wood of these giants has provided everything from tool handles to baseball bats, demonstrating humanity's long relationship with winter forest resources. Black ash trees, preferring the wetter areas of winter swamps and stream bottoms, create their own specialized ecosystems in these low-lying areas. Their bark, darker and more furrowed than their white ash cousins, contains compounds that make the wood naturally resistant to decay when in contact with water. Traditional basket makers have long recognized that black ash wood splits most cleanly when harvested during winter months, when the tree's moisture content is at its lowest and the wood fibers separate most readily. The paper birch groves that grace northern winter forests create some of the most photogenic landscapes in the temperate woodland, their white bark appearing to glow with inner light against the darker backdrop of evergreens and snow. These pioneer species excel at colonizing areas disturbed by fire or windstorms, their light seeds traveling great distances to establish new populations. Their bark, waterproof and durable, has provided material for everything from canoe construction to emergency shelter throughout human history in northern regions. River birch trees, thriving along winter waterways, display their distinctive salmon-colored bark that peels in papery curls, creating textural interest that becomes particularly apparent when snow accumulates in the bark's natural crevices and folds. These flood-tolerant trees demonstrate remarkable adaptability, surviving periods of both drought and inundation, while providing crucial erosion control along stream banks and riparian corridors. The American hornbeam trees, also known as musclewood for their distinctive smooth, fluted bark that resembles flexed muscles, create important understory structure in rich winter forests. These small trees rarely achieve great size but live for many decades. They're incredibly hard wood, earning them the alternative name of ironwood. Their winter silhouettes reveal graceful, zigzag branching patterns that create intricate shadows on snow-covered ground. Hawthorn trees scattered through forest edges and openings display their formidable thorns and dense branching structure that provides impenetrable nesting sites for small birds, while their persistent fruits offer winter food sources. These members of the rose family demonstrate nature's ability to combine beauty with defense, their spring flowers giving way to small apples that sustain wildlife through the coldest months. Native Americans recognized numerous medicinal uses for hawthorn, particularly for heart-related ailments. The Kentucky coffee trees that occasionally appear in rich winter bottomlands stand as monuments to the forest's prehistoric past, their large compound leaves having fallen to reveal distinctive branching patterns and persistent seed pods that rattle in winter winds. These trees represent remnants of forests that once supported now extinct megafauna, their large seeds apparently adapted for dispersal by giant ground sloths and other Ice Age creatures that no longer roam the landscape. Pawpaw trees, though more common in warmer regions, occasionally appear in protected valleys of northern winter forests, their smooth grey bark and distinctive winter buds revealing their tropical ancestry. These northernmost members of a largely tropical plant family produce the largest native fruit in North America, though their winter appearance gives little hint of the custard-like treats they provide during late summer and early fall. The understory shrubs that create the forest's middle layer take on entirely different roles during winter months, their branching patterns revealed, and their ecological functions shifted toward providing shelter and persistent food sources rather than the rapid growth and reproduction that characterizes their summer activities. Spicebush, with its aromatic twigs and bright green bark, provides important early nectar sources when its small yellow flowers bloom before most other plants have awakened from winter dormancy. Elderberry shrubs create natural thickets in moist areas throughout winter forests, their multiple stems rising from common root systems in graceful clusters that demonstrate efficient use of growing space. Their dried flower heads, now empty umbels, catch snow in delicate patterns, while their dark berries provide crucial winter nutrition for numerous bird species. Traditional medicine has long recognized elderberry's immune-supporting properties, particularly valuable during cold and flu season. The wild grapevines that drape between winter trees like natural cables demonstrate remarkable strength and longevity, their woody stems sometimes achieving impressive diameters over many years of growth. These climbing plants provide important structural diversity in forest ecosystems, while their persistent fruits feed wildlife throughout winter months. Their fibrous bark has provided cordage material for countless generations of forest dwellers who understood how to work with natural materials. Sumac colonies create distinctive winter landscapes with their fuzzy red seed heads persisting above snow level, providing crucial food sources for birds and small mammals during the leanest months. These fast-growing shrubs excel at colonizing disturbed areas, while their extensive root systems help prevent erosion on slopes and embankments. The tartness of sumac berries has made them valuable for both wildlife nutrition and human food preparation throughout history. The forest floor beneath winter snow becomes a protected environment where specialized communities of organisms continue their essential work at cold-adapted rates. Springtails, tiny, primitive insects, remain active throughout winter in this subnivean world, feeding on decaying organic matter and maintaining nutrient cycling processes that will support explosive spring growth when temperatures rise and daylight hours lengthen. Snow depth variations throughout winter forests create complex habitat mosaics that different species utilize in various ways. Areas with deeper snow provide better insulation for small mammals that tunnel beneath the surface, while windswept areas with thinner snow cover allow ground-feeding birds easier access to seeds and other food sources. These natural variations in snow distribution create the habitat diversity necessary to support complex wildlife communities. The mycorrhizal relationships between tree roots and soil fungi remain active throughout winter months, though at greatly reduced metabolic rates. These partnerships continue to transport nutrients and water between trees while maintaining the chemical communication networks that allow forest communities to coordinate responses to environmental stresses and resource availability. Research continues to reveal the sophistication of these underground networks that connect forest communities into integrated superorganisms. Soil organisms adapted to cold conditions maintain decomposition processes throughout winter months, ensuring that nutrients remain available for spring growth while preventing the accumulation of organic matter that could create anaerobic conditions harmful to tree roots. These cold-adapted bacteria, fungi, and invertebrates represent specialized communities that have evolved to function efficiently at temperatures that would shut down most biological processes. The role of winter forests in regional hydrology becomes particularly apparent during spring snowmelt periods, when these woodlands serve as natural retention systems that moderate flood peaks while recharging groundwater supplies essential for maintaining stream flows during summer drought periods. The forest canopy, understory vegetation, and organic soil layers work together to slow water movement and maximize infiltration rates. Wind patterns in winter forests create invisible architecture that influences everything from snow distribution to seed dispersal, with tall trees channeling air currents and creating turbulence patterns that affect local weather conditions. Understanding these wind patterns helps explain why certain areas consistently develop deeper snowdrifts while others remain relatively clear, and why some trees develop asymmetrical growth forms or lean in particular directions. The acoustic properties of winter forests change dramatically from other seasons, with cold, dense air and snow-covered surfaces creating unique sound transmission characteristics that affect both wildlife communication and human perception of forest environments. Some frequencies travel farther in cold air, while others become muffled by snow cover, creating natural acoustic conditions that influence how animals use sound for territory establishment and mate attraction. Traditional ecological knowledge preserved by indigenous peoples includes sophisticated understanding of winter forest resources and seasonal timing of optimal harvest periods for various plant materials. This accumulated wisdom represents thousands of years of careful observation and sustainable interaction with winter woodland ecosystems, demonstrating how human communities can integrate successfully with natural seasonal cycles. The medicinal plants available during winter months often contain their highest concentrations of active compounds, as plants store these protective and therapeutic substances in bark, roots, and other tissues during dormant seasons. Traditional healing systems worldwide have recognized that many medicinal plants reach peak potency during winter months, when stored compounds become most concentrated and accessible for human use. Winter forest crafts and traditional technologies utilize the specialized properties of cold season materials, from the straight grain of winter harvested lumber to the flexibility of bark and plant fibers that achieve optimal working characteristics during dormant months. These practices required intimate knowledge of how seasonal changes affect the properties and working characteristics of natural materials. The spiritual and ceremonial significance of winter forests across many cultural traditions recognizes these environments as places of purification, reflection, and renewal, where the stripping away of summer's abundance creates opportunities for deeper connection with essential life forces and natural rhythms. The contemplative qualities of winter woods naturally promote introspective states and personal transformation experiences. Wildlife adaptation strategies visible throughout winter forests demonstrate remarkable evolutionary solutions to seasonal survival challenges. From behavioral modifications that reduce energy expenditure to physiological changes that allow continued function at temperatures that would be lethal during active growing seasons. Each adaptation represents millions of years of natural selection pressure focused on winter survival requirements. Forest succession patterns become particularly visible during winter months, when different age stands display distinctive structural characteristics and species compositions that illustrate how woodland communities develop and change over decades and centuries of natural processes and disturbance events. Young forests look completely different from mature stands, demonstrating the dynamic nature of forest ecosystems. The integration of winter forests with human communities represents both historical relationships that sustain traditional cultures and modern opportunities for sustainable resource management that provides benefits for both people and wildlife while maintaining ecological integrity and natural process functions. Understanding these relationships helps inform conservation strategies that protect forest ecosystems while meeting legitimate human needs. Climate change impacts on winter forest ecosystems create new patterns of seasonal timing and species interactions, with shorter winters and more frequent freeze-thaw cycles affecting everything from tree health to wildlife reproduction timing and migration patterns. These changes demonstrate the interconnected nature of forest communities and their sensitivity to environmental shifts that cascade through multiple levels of ecological organization. Winter forest management practices must account for the specialized needs of cold season wildlife communities, while also considering how winter conditions affect tree growth patterns, soil stability, and long-term forest health and productivity. Sustainable forestry approaches in winter environments require comprehensive understanding of how seasonal cycles influence all aspects of forest ecosystem function and development. The winter forest serves as a living laboratory for studying adaptation, resilience, and cooperative relationships under environmental stress, with every survival strategy visible in these woods representing evolutionary solutions to seasonal challenges that provide insights applicable to understanding how natural systems maintain stability while adapting to changing conditions and environmental pressures. Restoration ecology projects in winter forest environments focus on re-establishing natural processes and species relationships that create resilient woodland communities capable of surviving seasonal extremes, while maintaining the flexibility necessary to adapt to changing environmental conditions and climate patterns. These efforts require patient, long-term approaches that work harmoniously with natural seasonal rhythms and ecological processes. The ethnobotanical heritage associated with winter forests includes traditional uses for numerous plant species that provided food, medicine, fiber, construction materials, and other necessities for indigenous communities throughout cold regions of the world. This accumulated knowledge represents sophisticated understanding of seasonal plant chemistry variations and sustainable harvesting practices that maintained resource availability across generations. Snow science within forest environments reveals complex interactions between weather patterns, tree canopy structure, and ground-level snow accumulation that influence wildlife habitat quality, soil temperature regulation, and spring flood potential throughout entire watersheds. Understanding these relationships helps predict how forest ecosystems will respond to different weather patterns and long-term climate scenarios. The winter forest stands as nature's masterpiece of patience, adaptation, and community cooperation, demonstrating through countless relationships and survival strategies how life communities not only endure but thrive through the most challenging environmental conditions. These woods remind us that true resilience often lies not in avoiding difficulties, but in developing the collaborative relationships and adaptive flexibility necessary to work harmoniously with natural cycles and seasonal rhythms. Forest photography during winter months captures not only visual beauty, but also the emotional resonance of seasonal transition and natural rhythm, with the interplay of light, shadow, texture, and form, creating images that speak to universal human experiences of change, endurance, and renewal. The simplified compositions possible in winter landscapes focus attention on fundamental design elements and the inherent beauty of essential forms. As we move through these deepest forest sanctuaries, we discover that winter woods offer profound lessons about the relationship between rest and productivity, demonstrating that periods of apparent inactivity are actually times of intense preparation and internal development. The trees around us show us that dormancy is not defeat, but strategy, a conscious choice to preserve resources and energy for the explosive growth and reproductive activity that spring will demand. The winter forest teaches us about the wisdom of seasonal rhythms and the importance of working with natural cycles rather than against them. In our hurried modern world, these quiet woods remind us that there are times for action and times for reflection, times for growth and times for consolidation, times for expansion and times for turning inward to gather strength for future challenges and opportunities. Each step deeper into these winter sanctuaries connects us more fully with the ancient rhythms that have governed life on Earth for millions of years, reminding us of our place within the larger community of living beings that share this remarkable planet. The forest invites us to slow our pace, quiet our minds, and open our hearts to the subtle teachings that winter woods offer to those willing to listen with patience and attention. The winter forest stands as testament to life's remarkable ability to find solutions to seemingly impossible challenges, demonstrating through countless adaptations and cooperative relationships how communities of living beings can not only survive, but flourish in conditions that test every aspect of their biological capabilities and evolutionary heritage. These woods remind us that resilience comes not from avoiding difficulty, but from developing the wisdom and flexibility necessary to work with natural forces and seasonal changes. In these quiet groves where time moves differently and silence holds profound meaning, we find renewal for our own spirits and inspiration for our own lives. The winter forest offers us permission to embrace our need for rest and reflection, understanding that periods of apparent dormancy are actually times of deep preparation and internal growth that make possible the creative and productive activities that define our most fulfilling and meaningful experiences. As our journey through these transformed landscapes continues, we carry with us the peace and wisdom that winter woods offer to all who approach them with open hearts and patient spirits, ready to learn from the masterful teachers that surround us in every snow-laden branch and every footstep that crunches softly on the pristine white carpet beneath our feet. The deeper we venture into these winter sanctuaries, the more we begin to understand that each grove holds its own particular medicine for the weary soul. Here, where frost has painted delicate fern patterns on fallen logs and ice crystals catch the pale light filtering through bare branches, we discover that winter forests are master healers, offering their quiet therapy to anyone willing to receive it. The ancient art of reading winter trees reveals stories written in bark and branch, in the way each species has adapted its form to survive countless seasons of cold and snow. Shagbark hickory trees display their characteristic bark patterns like living sculptures, the long strips curling away from the trunk in dramatic arcs that create textural masterpieces against the white backdrop. These trees have perfected the art of shedding their outer bark to prevent damage from ice and expanding wood, a strategy that turns necessity into natural art. American chestnut sprouts, those persistent reminders of a once mighty forest giant, continue their brave attempts at reclaiming their ancestral domain. Though the mature trees fell to disease decades ago, these root systems refuse to surrender, sending up new shoots each spring in defiant hope. Their winter presence speaks to the forest's memory, to the way ecosystems hold space for lost members while adapting to changed circumstances. The red oak trees that crown winter ridges display their distinctive bark patterns, deeply furrowed and dark against the snow. These giants can live for several centuries, their acorns providing crucial food sources for wildlife during lean winter months. Their leaves, though fallen, decompose slowly and continue to provide nutrients throughout the cold season, demonstrating how death becomes sustenance in nature's endless cycle of renewal. Black walnut trees stand as solitary sentinels throughout winter forests, their deeply ridged bark and distinctive branching patterns, making them instantly recognizable even at a distance. These trees create their own growing conditions through chemical warfare, releasing compounds that suppress competing vegetation, a strategy that ensures their dominance while creating unique understory conditions that support specialized plant communities. The graceful American elm trees, where they have survived the challenges that decimated their populations, display winter architecture of breathtaking beauty. Their vase-shaped crowns create natural cathedral spaces, with branches that divide and subdivide in patterns that follow mathematical principles found throughout the natural world. These survivors carry genetic treasures that may hold keys to future forest restoration efforts. Basswood trees, with their heart-shaped leaf scars now clearly visible on bare twigs, create some of the most elegant winter silhouettes in the deciduous forest. Their smooth, pale bark seems to glow in winter light, while their inner bark has provided fiber for countless generations of people who understood how to work with forest materials. The flowers these trees will produce in summer provide some of the finest honey known to beekeepers. The ironwood trees scattered through winter understories display their distinctive mussel-like bark, with smooth, fluted trunks that seem to flex beneath their thin covering. These small but incredibly durable trees rarely achieve great size but can live for many decades. Their wood so hard it was once used for tool handles and other applications requiring extreme durability. Their winter buds, small but perfectly formed, demonstrate nature's precision in protecting next year's growth. Hop hornbeam trees, close relatives of the ironwood, show off their papery bark that peels in vertical strips, creating surfaces that catch snow in intricate patterns. These understory trees produce small, hop-like fruits that give them their common name, and their extremely hard wood has made them valuable for specialized applications throughout human history. The wild cherry trees that punctuate winter forests display their distinctive horizontal lenticels, breathing pores that appear as light stripes across their dark bark. These trees will be among the earliest to bloom when spring arrives, their white flowers appearing in drooping clusters before most other species have begun to stir. Their bark contains compounds that have been used medicinally for respiratory ailments for centuries. Stream corridors cutting through winter forests create ribbon ecosystems that support different plant communities than the surrounding uplands. Here, where flowing water moderates temperatures and provides constant moisture, we find remnant populations of plants more common in southern regions. The sound of water moving beneath ice adds a musical element to winter's quiet symphony, a reminder that life continues to flow even in the coldest months. Spicebush thrives in these protected stream valleys, its aromatic twigs releasing lemony scents when broken or bruised. This understory shrub will provide some of the earliest nectar sources when its small yellow flowers bloom before most other plants have awakened from winter dormancy. Native Americans valued spicebush for both its medicinal properties and as a spice for flavoring food. The hemlock groves that occupy cool, north-facing slopes create natural sanctuaries beneath their evergreen canopies, spaces where snow rarely penetrates and the air carries the clean, resinous fragrance of these ancient conifers. Eastern hemlocks can live for centuries, growing slowly but steadily in the deep shade they create. Their graceful, drooping branches sweep almost to the ground, creating protected spaces where smaller creatures find shelter from harsh weather. Norway spruce trees, though not native to most regions where they now grow, have established themselves as important components of many winter forests. Their distinctive cones, hanging like wooden ornaments from upper branches, add architectural interest to winter landscapes while providing food sources for seed-eating birds and small mammals. Their dense branching creates crucial winter shelter for wildlife. The white spruce trees that thrive in northern regions display their characteristic four-sided needles and small cones that provide important food sources for crossbills and other specialized seed-eating birds. These hardy evergreens can survive extreme cold and serve as indicator species for boreal forest conditions, their presence marking the transition between temperate and northern forest types. Balsam fir trees, with their spire-like growth forms and aromatic needles, create some of the most classic winter forest scenes in northern regions. Their branches layer in perfect whorls, creating natural terraces that catch snow in graceful horizontal lines. The resin produced by these trees has been used for everything from mounting microscope specimens to traditional medicine for respiratory ailments. The understory ferns that remain green beneath snow cover demonstrate remarkable cold tolerance, their fronds continuing photosynthesis throughout winter months when most other plants have entered complete dormancy. Christmas ferns, with their leathery evergreen fronds, add touches of green to otherwise brown and grey winter landscapes, while providing important cover for small animals. Wild ginger plants, hidden beneath snow but still alive, prepare for their early spring emergence when their unusual brownish-purple flowers will bloom at ground level, pollinated by beetles and flies attracted to their carrion-like scent. These woodland herbs demonstrate nature's diverse approaches to reproduction and survival, using strategies that seem strange to human sensibilities, but prove highly effective in their ecological contexts. Trout lily bulbs lie dormant deep in the forest soil, their energy stored and waiting for the precise temperature and light conditions that will trigger their emergence as one of spring's earliest and most beautiful wildflowers. These plants demonstrate nature's ability to time biological events with remarkable precision, using environmental cues to coordinate their life cycles with optimal growing conditions. The winter forest floor reveals complex microtopography, usually hidden by summer vegetation, with subtle ridges and depressions that influence drainage patterns, snow accumulation, and growing conditions for different plant species. These small-scale landscape features create the habitat diversity necessary to support the incredible variety of plant and animal life that characterizes healthy forest ecosystems. Rock outcroppings scattered throughout winter forests become prominent landscape features when snow accumulates around their bases in distinctive patterns. These stone formations provide crucial habitat diversity, offering den sites for small mammals, basking spots for reptiles during occasional warm days, and growing sites for specialized rock-dwelling plants like certain mosses and lichens that add subtle colors to winter landscapes. The phenomenon of tree wells, circular depressions that form around large tree trunks as snow accumulates, creates unique microhabitats within winter forests. These wells form because heat radiating from tree trunks causes nearby snow to settle and compact differently than snow in open areas. Small mammals use these wells as travel corridors and feeding areas, taking advantage of the easier movement they provide. Ancient stone walls, remnants of long-abandoned agricultural activities, create linear features throughout many winter forests, their stones now serving as foundations for different plant communities and wildlife travel corridors. These historical artifacts demonstrate how past human land use continues to influence current forest structure and species distribution patterns, creating legacies that persist for centuries after the original activities have ceased. Fallen logs in various stages of decay create nurse log systems throughout winter forests. They're slowly decomposing wood, providing growing medium and nutrients for seedlings, mosses, ferns, and other plants that depend on the unique conditions created by rotting wood. These horizontal elements add structural complexity while supporting specialized communities of decomposer organisms essential for nutrient cycling. The mycorrhizal networks connecting tree roots throughout winter forests remain active beneath snow and frozen soil, maintaining the underground communication systems that allow trees to share resources and coordinate responses to environmental stresses. These fungal partnerships represent some of nature's most sophisticated cooperative relationships, creating forest-wide networks that function like natural internet systems. Soil organisms adapted to cold conditions continue their essential work throughout winter months, processing organic matter and maintaining nutrient cycling at rates perfectly matched to winter's slower pace. These specialized bacteria, fungi, and invertebrates ensure that when spring arrives, soil conditions will be optimal for supporting the explosive growth that characterizes forest awakening. The role of winter forests in regional climate regulation extends far beyond their local environments, with these woodlands influencing weather patterns, air quality, and water cycles across entire watersheds and beyond. the transpiration and photosynthesis that continue even during winter months, though at reduced rates, contribute to atmospheric moisture and oxygen production that benefits entire regions. Traditional ecological knowledge associated with winter forests includes sophisticated understanding of seasonal variations in plant chemistry, optimal harvest timing for different materials, and sustainable use practices that maintained resource availability across generations. This accumulated wisdom represents thousands of years of careful observation and respectful interaction with forest ecosystems during their most vulnerable season. The medicinal properties of winter-harvested forest plants often reach peak concentrations during dormant months, when plants store their most potent therapeutic compounds in bark, roots, and other tissues. Traditional healing systems worldwide have recognized that many medicinal plants achieve maximum potency during winter, when stored compounds become most concentrated and stable. Winter forest crafts utilizing cold season materials required intimate knowledge of how seasonal changes affect the working properties of wood, bark, and plant fibers. From the straight grain of winter-cut lumber to the flexibility of bark harvested at optimal times, these traditional skills demonstrated sophisticated understanding of how environmental conditions influence material characteristics. The acoustic environment of winter forests creates unique soundscapes that change throughout the season as weather patterns shift and biological activity fluctuates. The clarity of cold, dry air allows sounds to travel farther and with greater definition, while snow cover creates natural acoustic dampening that filters and modifies the forest's sonic signature in fascinating ways. Wildlife tracking in winter forests reveals complex stories of survival, social behavior, and resource use written in snow and preserved until the next weather event erases the evidence. Learning to read these tracks and signs opens windows into hidden dramas of predation, courtship, territorial disputes, and daily survival routines that unfold largely unseen by human observers. The winter forest serves as a masterclass in resource conservation and energy management, with every species demonstrating strategies for minimizing expenditure while maintaining essential life functions. From behavioral modifications that reduce unnecessary activity to physiological changes that improve cold tolerance, these woods showcase countless solutions to seasonal survival challenges. Forest succession becomes particularly visible during winter months, when different age stands display distinctive structural characteristics and species compositions. Young forests dominated by fast-growing pioneer species look completely different from mature stands with widely spaced large trees, illustrating how woodland communities develop and change over decades and centuries of natural processes. The integration of winter forests with modern human communities presents both challenges and opportunities for sustainable resource management that benefits both people and wildlife while maintaining ecological integrity. Understanding historical relationships between forests and human cultures helps inform contemporary conservation strategies that protect these vital ecosystems while meeting legitimate human needs. Climate change impacts on winter forest ecosystems create new patterns of seasonal timing and species interactions, with shorter winters and more frequent freeze-thaw cycles affecting everything from tree health to wildlife reproduction cycles. These changes demonstrate the interconnected nature of forest communities and their sensitivity to environmental shifts that cascade through multiple levels of ecological organization. The winter forest stands as living proof of nature's remarkable ability to create beauty and meaning from apparent limitation and challenge. In these quiet groves where life has learned to thrive despite harsh conditions, we find inspiration for our own journeys through difficult seasons, reminding us that patience, adaptation, and community support can carry us through any winter we might face. As we continue our gentle exploration through these transformed landscapes, we discover that winter forests offer more than beautiful scenery or interesting natural history. They provide profound lessons about resilience, cooperation, and the wisdom of working with natural rhythms rather than against them. Each bare branch against winter sky becomes a teacher, each snow-covered path an invitation to deeper understanding of the cycles that govern all life. The winter forest reminds us that rest and reflection are not empty spaces in life, but essential periods of preparation and renewal. Like the sleeping trees around us, We too need seasons of quieter activity, times when growth happens internally and energy is conserved for future creative endeavors. In the patient example of these winter woods, we find permission to embrace our own need for stillness and contemplation. Here, where silence holds profound meaning and every footstep seems magnified in the crisp air, we learn to listen not just with our ears, but with our entire being. The winter forest teaches us that the most important communications often happen in whispers, that the deepest truths reveal themselves only to those willing to slow down and pay attention to subtle signs and gentle teachings. As our journey through these winter sanctuaries continues, we carry with us the peace and wisdom that these transformed landscapes offer to all who approach them with open hearts and receptive spirits. The forest invites us to find our own rhythm within its seasonal song, to discover our place in the larger community of life that surrounds and sustains us through every season of our existence. The winter forest's deepest teachings emerge only when we allow ourselves to be completely present in its embrace, when we stop trying to analyze or categorize every experience and simply allow the woodland's ancient wisdom to wash over us like gentle snowfall. In these moments of complete receptivity, we begin to understand that the forest is not separate from us, but part of the same living system that connects all existence through invisible threads of breath, energy, and shared cellular memory. The white oak trees that anchor these winter landscapes demonstrate mastery of the art of longevity, their massive trunks bearing witness to centuries of seasonal cycles, while their deeply lobed leaves, though fallen, continue to nourish the soil community that supports the entire forest ecosystem. These monarchs of the woodland have learned the secret of true sustainability, growing slowly but steadily, taking only what they need while giving back far more than they consume through their generous provision of habitat, oxygen, and beauty. In the quieter corners of these winter woods, where deer paths wind between ancient stumps and new growth reaches toward filtered light, we discover how the forest continuously reinvents itself while maintaining essential continuity. Young saplings rise from the nutrient-rich soil created by their predecessors, carrying forward genetic memories of countless previous generations, while adapting to current conditions with remarkable flexibility and resilience. The red maple trees scattered throughout these winter groves prepare for their spectacular spring awakening by concentrating sugars and nutrients in their tissues, their winter buds already containing miniature versions of the flowers and leaves that will burst forth when temperature and light conditions trigger their emergence. This forward planning represents nature's profound understanding of timing and preparation, demonstrating how success often depends on anticipating future needs rather than simply reacting to present circumstances. And so our gentle journey through these winter sanctuaries draws to a peaceful close. We've wandered together through cathedral groves and quiet clearings, witnessed the elegant architecture of sleeping trees, and discovered the hidden life that thrives beneath winter's patient blanket. These woods have shared their ancient secrets about endurance, adaptation, and the profound wisdom of seasonal rest. May the peace we've found here stay with you long after the last snowflake melts. A reminder that even in life's coldest seasons, beauty and renewal are always waiting just beneath the surface.